Shalom to you and welcome. I hope you're keeping strong and healthy. Washing your hands. All right, today in this video, we are going to look at simple interest. Simple interest is a function, a linear function. It's a linear function, a function of a line of money over time. Okay, how much amount you gain. If you invest some amount, how much you will gain over time. So we use it to determine future values. It could be if you put a money in a bank, how much you're going to get in the future, or if you loan a money, get a loan, how much you're going to pay later. Okay, so we're going to calculate simple interest and then derive the formula for future value, and then use the simple interest to formula on discounted loans. Now, simple interest is calculated as a percentage of the principal. Principal is the initial amount you put in. Simple interest is money, is amount. But simple interest rate, R, is the percent of that money. I mean, the money represented in percent per 100 or compared to a number over 100. So it's very important to know what each letter represents. I represent the interest amount, the money, is the principal, the initial amount, times the rate. And this rate is always over 100 because it's in percent. So anything percent is out of 100. So normally, actually, I would rather, because sometimes people forget that, I would put this all over 100 to remember that once rate is involved, rate is about 100. And then time is always in years, the number of years. Okay, it's very important to remember that time is always calculated in years. Okay, I moved this. See, I wrote that here. All right. So therefore, if you find the total or the final amount, okay, A, the amount you will get at the end, is common sense will tell you we take the interest you earned, and then add the principal, the original amount you started with. And since interest, or rather I'll write it here, interest is principal times rate times time, all over 100 if you wish. Then we can use substitution and replace this I with P R T plus P. Okay, so once we substitute this, you see there are two terms here, PRT and P. P is the same. So we can factor P out. See, there are two terms. If we factor out T, we're going to have RT left here, plus 1. So these two equations are the same. Here is in simplest form, we factored out P. But this is the future amount formula. The future amount, sometimes you can also see it as A equals P 1 plus RT. So because addition is cumulative, so whether you say RT plus 1 or 1 plus RT is the same thing, but you need to remember R is always over 100. So, but to make it look nicer, just kind of omit the 100, but remember that. So here the future value, A is for final value, P is for initial value, the principal, and then R is the interest rate, and then the time in years. Okay, so tips to remember: simple, write out the formula and then write out all the information you are given, then simply plug in the numbers and then solve the equation for the variable that is needed. Okay, sorry, I'm gonna on this, I need the music. All right. right, let's do an example. Okay, Mike, oh no, I'm gonna use maybe yellow. Mike borrowed 1,700 on a loan, and the future value is going to be 1820 in 6 months. Determine the loan's simple interest rate. So we are looking for the interest rate. Since it's simple interest, we are going to, and then we have the future value. So we're going to use the future value formula, which is future value amount equals the principal plus the interest, which is principal times rate times time. Again, I would like to put this over 100 so that we don't have to worry about multiplying by 100. Once we get the rate, solve for R, we know that the 100 has already been counted for. So we just substitute. The future amount is 1820. The principal is the amount we borrowed. So 1700 plus, here we're going to put that in parentheses. The principal is 1700 times the rate is R over 100. We don't know that. We are looking for it. Now, the time is 6 months. 6 months, but we have to make it year. It has to be time in years for all simple interest. So how many years in 6 months? It's going to be 6 out of 12. So which is 1/2 when we simplify that. Okay, so now we do the algebra to solve for R. Since this is addition, I think it's easier to just subtract 170 from both sides. If we subtract 1700 from both sides, and that would give us 120 here equals, and we can go ahead and multiply. I can actually cross out this to make it easier. Go ahead and multiply 1,700 times 6. 1,007 times 6. So I get 10200R over 1200. And we can go ahead and cross out these 2 zeros. So multiply both sides by 12. Or if we divide this, we get 120 is equal to 8.5 R. So you can just divide 102 divided by 12. That's since it came out even. If you have a number that keeps going and doesn't terminate, then I would multiply both sides by 120. So, and now we can go ahead and do 120 divided by 8.5. And that will finally give us about 14.1%, since they ask us to round to the nearest tenth of percent. So 1 decimal place, and that is the rate, interest rate for that. Okay, let's try another one. How much must you invest? How much must, so this, you are looking for the initial amount you have to invest to have a total amount of 14,000 balance in your account in 6 years if the interest rate is 9.5%. Okay, so again, we use the final amount. Since we are looking for the principal, it might be easier to just use the simplified version of the final value return over that, where principal is factored. I see that easier because P is one number than the other one, but when you're looking for rate and time, is kind of easier to use the distributed form. So substitute. Define future amount is 14,000, and then the principal P we are looking for 1 plus, and here we're going to have the R, but this TR is kind of multiplying themselves, so make sure you follow the order of operation. It's kind of helpful to use parentheses all the time. So the rate, we know we can simplify it here. The rate is 9.5%, which is the same thing as 9.5 over 100, which can also be simplified to move the decimal 2 places to the right, to the left, 0.095. Okay, so if you can simplify the rate like this before you put it into the formula, it will make things a lot easier. So 0.095 times the time. Okay, the time is 6 years. Since it's already in years, we don't need to do any adjustments. So just write times 6. But if it is a month, then we have to write it in years. Okay, we can go ahead and multiply that by 6. And that will be 1 plus 0.557. And we add that, this is still P. We add it, we get 1.57 multiplied by P times P. Okay, so now we are just doing the algebra arithmetic solving for P. So now divide both sides by, can I go ahead and divide both sides by 1.57. So P is going to be that. It's 9.197 and so forth. So which will be approximately, it's going to be approximately 8,917.20. Okay, this is the amount you have to put in to be able to have a balance of 14,000 in 6 years. Okay, that's the principle. Now, discounted loans. Sometimes when you borrow money, you loan money, the lender would like to take away the interest at the beginning and then give you the amount that is left. So that is called discounted loans. The discount is the interest that is taken away. So therefore, we can use the interest formula to find that discount, since it's the same thing as the interest. Then to find the net amount you're going to receive after that, it makes sense to just take the initial loan and then subtract that interest you found here to know how much you will receive as your principal. Okay. So now, let's do a problem. You borrow 2,000, and then it is discounted 7%. So since it is discounted, it doesn't mean that 7% is the interest. So the interest rate is actually different, which we'll find later. So for the period of 8 months. So this is the money you borrowed. That's the loan. So find the loan's discount. So to find the discount, the discount is the same thing as the interest, which is principal times rate times time over 100. So which is going to be the initial loan times the rate, which is 7 over 100, times the time, which is 8 months, which we make it a year, so 8 over 12. And we can go ahead and simplify all of that. So multiply that. So the interest is going to get 93.33. So that's about how much discount the interest is going to make in 8 months. So we are going to subtract that. So B, the net amount is going to be loan minus the discount we just found. Okay, so the loan is 2,000 minus 93.23. So we're going to get 1906, 67. So that would be the net amount that you will receive initially to start with. That's going to be your principal. Okay, what is the actual interest rate to the nearest tenth? All right. Now, we can, that's the C. Since we already have the interest, we can use the interest formula. Okay, RT. Again, good to put that 100 so we remember. Now, if we don't have the interest, then we can use the whole. But we have the interest. The interest is 93.33, which we just found. Now, the principal is going to be the money, this one, the net money, because that's the amount you received, you started with, to start with. You did not receive the 200, the 2,000, you received this amount because they took away 93.33 cents in before they gave you the money. Okay, 1906. So we're gonna put 1906.67 times the rate, or rather I will put the time. The time is, again, is 8. The time is 8/12. And the rate we are looking for. And now we can go ahead and simplify that. Plug in the calculator. So multiply and 12. So this we can also reduce the 12. This is 93.33 equals, multiply the 8. You can simply reduce this 8 to 2/3. So that's 2/3. So if you multiply 1,000 times 2, 1906 times 2, we get 3813.34 times R all over 3 times 100 is 300. Okay, so if you divide this, you may get a decimal that does not terminate. So I would multiply both sides by 300, and that would give us 27999 equals 3813.34 R. And now we can divide both sides by that. And that would be okay if we get a decimal now. So go 27999 divided by 3813.34 will give us the rate. And that will be about 7.3%. Okay, and you see, in the problem, it looks like the rate is 7%, but the actual rate is 7.3%. So if you use this 7.3% and then use this amount that is given to find how much amount the person will actually pay in 6 months. Okay, that will be over 2,000. But then, now because they have already removed the interest, the person is going to pay 2,000. Okay. All right, let's see if we can do one more. Come on. All right. It's a good one applied to graph. Okay, see the graph? They gave us the function as a function of the amount and the time, the number of years. Determine the slope of the function. Just looking at the equation, we know the slope, just like y equals mox plus b, right? So we can see that t is the x, so the slope is 25. So the slope is 25. And so that's like $25 for 1 year. So that means every year, so what it means, every year interest is $25. And then how much was initially deposited? So to find the initial amount, we look at the graph when time is 0. When it started, it's 400. So it's 400. We can also look at the equation. It's shown that's the y-intercept, 400. And then what is the interest rate? All right, the interest rate, if we match, let me write down. If we match the interest, the amount is going to be the interest plus the principal. Then kind of match this. They have the A of t, which is the same thing as the total final amount, equals 25t plus 400. So if we match these two equations, we can see the final amount. The final amount function PRT is the same thing as 25 because the principal is 400. Therefore, we can actually set, we can actually set the PRT is going to equal, and of course PRT over 100 is going to equal 25t. But we see here we can cross out these two t's. And again, PR, the rate is out of 100, is equal to 25. But we know the P, which is the principal, 400. We can actually substitute that. So then we can get, so it's 400R over 100 equals 25. And this can cross out, okay, 400, the 0, 0, you just do the algebra, simplify this. And so we have 4R equals 25. And so the R is going to be 25 divided by 4. So 25 divided by 4 is 6.25. So it's 6.25%. Okay, that's it. The question here is down to how long will it take to have a balance of 1,000 in the account? So we can just do that here. So we are looking for A of 1,000. The final amount is going to be 1,000. So 25t plus 400. So we just solve the equation. Substitute, we can subtract 400 from both sides first. Okay, that would give us 6 plus 25. And we can divide 600 divided by 25. 600 divided by 25 is 24. So it's going to take 24 years. Okay, 24 years. 24 years to have a total of 1,000 in the account. Good problem. All right, peace be with you. Stay safe. And you can do your assignment now. Shalom.